Man, that was good. Sodas are really good. They taste a lot better when they're cold, though. I wonder why that is. They just seem to be a lot more fizzy. There's a lot more gas dissolved in them. But anyway, this is the video for the review for your test tomorrow. And so I just picked out about 5 problems, and I'm going to run through those. These are off of your review, so if you haven't accessed that, you can find it on the Edline page under the notes. Find the Unit 10 review, and we're just going to go through some problems that I think you guys might want to discuss some hot spots. So let's get started with that, shall we? With problem number 4, what is something that can be done to increase the amount of solid solute that can be dissolved in a solution, and what is something that can be done to increase the amount of gaseous solute that can be dissolved in a solution? Okay, so before I answer these questions, I really want to point out here, pay attention in this question. I am not talking about the rate or how fast it dissolves. I want to increase the amount, not get it in there faster. This is why I'm not going to tell you to agitate it, remember stir or shake it, or increase the surface area. Instead, think back to the lab that we did with the sugar. In order to increase the amount of sugar that I could dissolve in that water, we increased the temperature. We heated it up to almost boiling, and then we could get all that sugar in there. Okay? Now, as we talked about earlier, in order to get more gas into a liquid, we need to decrease the temperature. This is why sodas have more fizz in them when they're colder, is because we can get more gas, more carbon dioxide to dissolve in the soda. Next problem I want to take a look at is number 5. This is a calculation problem. You can see it at the top there. You can look on your paper. Okay. The very first thing that I'm going to do is I'm going to put that number, that 1 times 10 to the third milliliters, into the calculator, and I'm going to get an actual number for it. And when I do that, 1 times 10 to the third, that is 1,000 milliliters. So I'm going to write that number down, or you can keep track of that number. We have 1,000 milliliters, okay? Now, also, I can't leave that in milliliters because the other number that was given to me was in liters. And so I have to make them the same. I'm going to choose to convert that 1,000 milliliters. That's just 1 liter. Okay, so real straightforward, real simple. This number right here is going to become 1 liter. All right. Now I can use this formula. I'm looking for the new concentration, so I'm looking for the new M2. So I'm going to get M2 by itself. I'm going to divide by V, cancel that out, rewrite my formula, and now I'm going to plug in numbers. Okay, here was my concentration, and here was my original volume, 1 liter. And then down here is the 4.2 liters, and that gives me 2.38 molar. Okay. The next problem, I'm going to do number 7, another calculation problem, but I really wanted to go over this because it says how many grams. Okay, we don't have a formula or anything that gives us grams, okay, not this unit. The closest we can get is moles. So we need to find the moles and then convert it into grams. But this is just a real straightforward, simple problem. I've had a number of people ask me too, how do you know which formula to use? How do you know? Guys, on the previous example, we were changing the concentration. Something was changing. New volume, new concentration. That's when you use the previous formula. But for this one, nothing's changing. It says, hey, I got 0.5 liters. I got 1.5 molar solution. Nothing changed. This is what I have. And so that's when I'm going to use this formula right here. But we got to get moles by itself, so I'm going to multiply both sides by the volume, cancel these out, rewrite my formula, plug in my numbers, and this is how many moles I get. But I'm not finished. I guarantee you that'll be an answer choice though. But you're not finished because the problem very specifically said how many grams. And so what I'm going to do is I'm going to take this and convert it just like we did before. I'm going to put this over 1. This is grams of sodium chloride, so that's NaCl. Moles goes to the bottom. Grams goes on top because that's what I'm converting to. I'll go to my periodic table and I'll add those together. 58.443 is what I get, and when I multiply those, I get 43.8 grams of NaCl. Now I'm going to skip all the way ahead to number 15. Okay? It says you're studying a solution in order to test this solution, I'm going to dissolve a small crystal into the ion into the solution. What should you see if the solution is unsaturated? Well, remember, unsaturated means you have less than the maximum or below the maximum amount of solute in that solution. Well, if I don't have the maximum, that means some of it can dissolve. I probably won't see all of it dissolve unless I stir it up or heat it up, of course. But I'll at least see some of it. So what I'm going to see on the bottom of the beaker then, when I drop that crystal in, is some, but not all of it, will fall to the bottom. So like for instance, if I drop 1 gram of sugar into an unsaturated solution of sugar water, I'll see a little bit of that sugar fall to the bottom probably. Might see it all dissolve, but most likely I'm going to see all of it. I'm going to see some of it fall to the bottom. Now, the problem changes if it's saturated. If the solution is saturated, well, saturated means that the maximum amount of solute has been dissolved in there. Well, if it's the maximum, I can't get any more. There's no more room for it to dissolve in there. So that means everything I put in will fall to the bottom. I'll see exactly what I put in fall to the bottom if it's truly saturated. The weird one, though, is the next one. What if it is super saturated? Well, if it's super saturated, that means I have more than the maximum dissolved in that solution. It's almost like a house of cards. It's not very stable. All those crystals are kind of floating in there. They're not quite, it's not just a simple little bump or something can cause some of those crystals to fall. And so when I drop some of that sugar in there, not only am I going to see my sugar fall to the bottom, but it's probably going to knock some of the other loose. I'm actually going to see more than what I put in fall to the bottom. So if it's unsaturated, you'll see less. If it's saturated, you'll see exactly what you put in. And if it's super saturated, you'll see more than you put in fall to the bottom. Last question I want to take a look at, and this will take a little bit of work, is I want to take a look at number 17. We have 6 compounds, and I wanted you to take a look at your periodic table, and I wanted you to see, or I wanted you to look at the back of the periodic table, rather, and see which ones were soluble. Now, take a look real fast at this periodic table. That some of these compounds will be soluble in water, and some of them will be insoluble. Okay, but of course, we've also got these right here. Now, looking at that, we have to pay attention to, when we look for our compounds, we really have to pay attention to not just which block we're in, whether it's soluble or insoluble, but we're also going to have to check and see if there are any exceptions. So we take a look at the very first one. The very first one was ammonium chloride, NH4Cl. So looking at this chart, we either need to find ammonium or chlorine, and they actually both happen to be on here. It doesn't always work out that way. You just need to find one. So I'll look for the first one. There's ammonium right there. And ammonium is soluble in water, and there are no exceptions to this. So if it has ammonium, it is soluble, and so therefore ammonium chloride is soluble. Okay? If I take a look, we'll take a look at the next one. That was silver bromide. So now I need to either find silver or bromine, and looking on here, here's bromine right here. Bromine is soluble in water, but if we look at the exceptions, if it's mixed with silver, then that is an exception, and so actually silver bromide is not soluble in water because that is an exception to this, and so therefore silver bromide is insoluble. So you can do the same thing for the others, and this is how you'll get these answers right here. Okay. If there are any other questions on this, if you're not quite sure about something on the review, guys, as you're studying tonight, please make sure, email me, send your emails to this address, thompson.chemistry.lehs@gmail.com. Go straight to my phone. I'll be able to answer your questions as quickly as I can. And make sure you guys study. Good luck on your test tomorrow.